we can use bool data type to represent boolean values. Only two values are allowed for bool data type, that is true and false. Now internally Python is going to treat this true as 1 whereas the false as 0. For example, here we have taken b equal to true. So when I'm going to verify what is the type of b, I'm going to get the class that belongs to is bool. And mostly when we use this bool data type for comparison, let's say here we have taken num1 equal to 50, num2 equal to 20, and I'm just verifying whether num1 is greater than num2. So 50 greater than 20 is true. So hence this result is going to carry the boolean value, which is nothing but true. And because true and false represent some integer values, I can also use something like this, where what I'm trying to do is we are trying to add true with true. So as true represent 1, this true represents 1, hence the result is 2. Similarly, true minus false, because true is 1, this false is 0, so hence the result is 1. Say b equals to, I can assign true, and when I'm printing b, I'm getting true. If I want to check the type of b, I'll be getting class bool. Likewise, suppose num1 equals to 50, say num2 equals to 40, and I'm going to check num1 greater than num2, so I'm getting the result as true. And when I'm trying to add, suppose true is added with true, so we get the result as 2. Similarly, if I'm writing true minus false, then I'm getting 1, because true is 1, false is 0. The next data type is binary types, where we deal with two types of binary types. One is your bytes, another one is your byte array. Now bytes data type is immutable sequence of integers, and the range can be from 0 to 255. So when I say immutable, I mean we cannot modify the values. And where we use normally this binary data, like this bytes data type, is in form of images. When we want to store images, when we want to store some audio files, some video files, in case of some executable files, and some network packets. Now how do we create this bytes object? There are two ways to do that. One is by using the bytes function, and another one is by using the bytes literal. Now let us see the first one. Using bytes function, how can we generate it? So here we have taken this bytes function with a symbol. Function symbol is this, and within this I am preparing a list of items like 72, 101, 108, 108, 111. In fact, when this object is created, its corresponding alphabets are being considered. Like 72 represents your H, and this represents your E, then this is L, this is L, this is your O. So by the end of this, when I'm trying to print the value of this bytes underscore obj, we are going to get the output as hello. And you can see whenever the output is displayed, it also precedes with small b, which indicates that this is a binary object. So here we have created a byte object by using bytes function, where we have taken this list of numeric values which represents corresponding characters. So when I'm going to print bytes obj, so I'm going to get hello. As you can see, this b is preceded along with this hello, indicating that this is a binary object. The second way of creating binary type is you're using bytes literals. Now bytes literals are basically created by prefixing a b followed by a string enclosed within quotes. Like you can see here, we are taking bytes obj, b is the prefix, and this is the string which is enclosed within single quotation mark. So when I'm going to print the value of this, we are going to get b followed by hello. Now the bytes object are commonly used in file input output. When we are reading or writing contents from and to a file, you need to work on binary data so that you can save memory. And while network programming, when we work with network sockets, you often need to send and receive binary data. In cryptography also, many cryptographic algorithms operate on binary data. And image and audio processing, you may need to manipulate binary data while working with images or audio files. So we have created one object here with preceding with B followed by hello. So when I'm going to print this bytes obj, we'll be getting the same string hello but preceding with B, indicating that this is a binary object. Now another binary type is your byte array. So byte array is similar to your bytes except the fact that it is mutable. I mean, we can make the necessary changes, and when it comes to the sequence of integer or the range of values what it can carry, it is between 0 to 255. Now how do I create a byte array object? So we can create the byte array object by using a byte array function. So let's say we are calling this byte array function, and where I am mentioning the string or the sequence of characters here, and this is the coding format or encoding scheme we say, and this byte array is now created by using this hello. So when we try to display the value, you can see it always precedes with this byte array followed by this B and the hello, the string whatever we have created. So this byte ARR is created for the byte array. So when I'm going to print this byte ARR, we are going to get byte array being preceded along with this B, which indicates that this is a binary object. So we can also create a byte array object from a list of integers, like same byte array function we have taken. So rather than passing string directly, I can also pass a list of sequence of integers, like the integers we have passed here, 5 integers, 72, 101, 108, 108 and 111, which actually represent the characters like H, E, L, L, O. Now when I'm going to print the value of this, I'm going to get the same result what we have got earlier. So you have two options, either you go by using the string directly, otherwise you can take the help of the list of integers to represent a string. So none is a special data type which represents the absence of a value or a null object reference. So what is the basic characteristics of none? It is immutable. I mean, none is a immutable object, means we cannot change its value. Secondly, falsy. So none is considered as a falsy value, meaning that is treated as a false in Boolean context, because we understand in Boolean context that is true and false. So every time this none is usually treated as a false. Non-iterable means none is not an iterable object, meaning that it cannot be looped over or we cannot index it. Now what are the various areas where none is useful? When we set the default values, if you do not know the exact value what you want to keep, so you can assign none as a default value for the variables. At the same time, you can also specify as the function arguments. Now null object references, okay, these none can also be used as a null object reference, indicating that a variable or attribute does not have any value initially. Function return values. Whenever we define functions, there are cases where the function may not return any value. So in those cases, we can use this none as a return value, saying that this function has no return type or it does not return any value or return a null value for that matter. For example, let's say we are assigning none to this x. When I'm going to check if x is none, it is giving me true. Whereas if I'm checking x is not none, I'm getting it as false. Let's say we are assigning x equal to none. So when I'm going to print x, I'm going to get nothing out of it. Okay. So when we check x is none, so we are going to the result as true, because none is none, that is true. So when I'm doing x is not none, we are getting it as false.